In this video, I show you how I built a screen recorder with Blazor and .NET. Let me demo the app. The user can click the Start Sharing button, then select the screen, and if he wants to share system audio, he can click this toggle and click Share. Then we can press the Record button to start recording. We can pause and resume. And finally, we can stop the recording. We can click the Download button to download a recording. Let's play it. And we can click the Restart button to start over. The source code for the app is available on GitHub. Have a look at the video description. First, how would someone go about building an application like a screen recorder? Well, you would need to use a set of APIs. An API stands for Application Programming Interface, and it is basically a set of functions that provides certain behavior. So we build our application on top of this API. Now, there are certain APIs that are built directly into web browsers like Chrome, Firefox, and Edge. These APIs are called browser APIs. Among these, we have the Canvas API that is used for drawing 2D graphics and animations on a canvas element. Then we have the Geolocation API that pinpoints the user's longitude and latitude via GPS or Wi-Fi. Of course, we have the most essential API, the DOM API, that lets us dynamically read and modify HTML and CSS. Of these, we are interested in the MediaDevices and the MediaRecorder APIs. The MediaDevices browser API provides access to devices like screen, camera, and microphone, whereas the MediaRecorder API gets the stream from MediaDevices and records it. Now, since web applications are rendered in a web browser, a web application can use these browser APIs and offer the desired functionality. So let's say our technology of choice for building this web application is Blazor, but then from Blazor, how do we talk to these browser APIs? Blazor provides a feature called JavaScript Interop that lets us talk to JavaScript. So from a .NET method, we can invoke a JavaScript function, and from a JavaScript function, we can invoke a .NET method. This JavaScript function may be present in a third-party JavaScript library whose functionality we want to consume from our Blazor app, or this JavaScript function may wrap a browser API that we want to consume from our Blazor app. So there we have a Blazor screen recorder that uses JavaScript Interop to talk to JavaScript functions that wrap the MediaDevices and the MediaRecorder APIs. Let's review the source code for our app. Inside the shared folder, we have a Razor component called screenrecorder.razor, and right next to it, we have a co-located JavaScript file called screenrecorder.razor.js. If we take a look at the screen recorder component, we see it contains a div element with some bootstrap classes applied to it. Inside the div, we have a video element. This video element is used so that once we start sharing our screen, the screen gets displayed inside the video. And we have a set of inline styles and attributes applied to the video element. Below the video element, we have another div, and inside that div, we have a switch statement. For the switch expression, we have a recorder state enum. This enum can be found inside the enums folder. This enum represents different states involved in the recording process. Initially, the recorder state, as you can see here, is set to recorder state.idle. So it starts off by displaying the Start Sharing button. So when the user clicks on the Start Sharing button and the screen gets shared, inside our code, right here, we set the recorder state to recorder state.notRecording. So now, this case gets hit and we see the record button. Likewise, once user clicks on the record button and the recording process begins, the recorder state is set to recorder state.recording, and we will see the pause, resume, and stop buttons. And we have a Boolean field called isPaused, which is initially set to false. So if isPaused is false, the pause resume button will have a bootstrap class of btn success, and if isPaused is true, it will have a bootstrap class of btn warning. Likewise, if isPaused is true, the text on the button will be resume, otherwise it will be pause. And finally, when user clicks on the stop button, it will stop the recording process, and eventually the recorder state will be set to recorder state.recording complete, and we will see the restart and download buttons. The download button lets us download our recorded video, while the restart button lets us start over. Down below, right inside this markup, we have a way to display any exception message. That is, any error that might occur. Now, before we take a look at the rest of the code, I would like to let you know about the website that I have been working on called spanclip.com. It's a screen recorder app that lets us record screen as well as camera and mic audio. The tool itself is built using Blazor and it's completely client-side. And by the way, it uses the same concepts discussed in this video. Let's examine the code block. We have a component parameter called system audio. So this can be set from a parent component. Next, we are overriding the onAfterRender async lifecycle method for this component. This lifecycle method gets executed once the component is rendered. So inside this method, we can start doing any JavaScript interop. The onAfterRender async lifecycle method has a parameter called firstRender, which we can use to check if this is the first time the component is being rendered and not a re-render. Let's focus on this piece of code here. We're calling await.js.invokeAsync. This JS property is of type IJS runtime. We have injected this service up here. The IJS runtime exposes two methods called invokeAsync and invokeVoidAsync. The invokeAsync method is used to invoke a JavaScript function that returns a value of type t, whereas the invokeVoidAsync method lets us invoke a JavaScript function that does not return any value. Here we are calling invokeAsync, and the first parameter is the name of the JavaScript function that we want to invoke. Here we have a special function called import, and the following parameters are any arguments that we want to pass to the JavaScript function. In this case, we are passing in the path to the JavaScript module. This module is nothing but our co-located JavaScript file. And if we open this file, we see it contains a set of functions that have the export keyword. This turns the JavaScript file into a JavaScript module and enables a feature called JavaScript isolation. Once we import this JavaScript module, we get back an IJS object reference, which is just a reference to a JavaScript object. So we specify the type argument as IJS object reference, and we store it in the field called module. And we can use this module reference to invoke any functions on the co-located JavaScript file. Also, we need to implement iAsync disposable with its disposeAsync method and dispose of the module when the component is disposed. Let's move on to the start sharing button. Inside the start sharing event handler method, we are constructing an anonymous type called screen options. We're setting video to true and audio to the value supplied by system audio component parameter. So this object is called constraints and it is required by the MediaDevices browser API. On the module reference, we are calling invokeVoidAsync, passing in the name of the JavaScript function called addScreenToVideo. To this JavaScript function, we are passing in the video element, screen options, and .NET helper. The video element is of type element reference, as you can see here, and this is assigned as the href attribute of the video element. So what this lets us do is, it lets us take this video element and pass it to JavaScript code so that we can modify it there. The .NET helper field is of type .NET object reference of screen recorder that we can see right here. It lets us invoke a .NET method from a JavaScript function. Note that we need to initialize .NET helper on the first render by calling .NET object reference .create this. Let's examine the addScreenToVideo JavaScript function now. Ignore this piece of code, we'll come back to it later. Here we are using the MediaDevices browser API. So await navigator.mediadevices.getDisplayMedia, passing in the screen options or constraints, and we are storing the returned stream. Once again, let's ignore this. Then we are setting video elements src object to the returned stream. and we are setting video element dot muted to true. So now the screen gets previewed in our video element. Back to our screen recorder component, we are setting recorder state to recorder state dot not recording, which displays the record button. Now we are wrapping the entire JavaScript Interop code inside a try catch block so that if any exception occurs within the try block, it will be caught inside the catch block as a JS exception. And we are taking the message from the exception and storing it in the message field, and we are displaying the message right here. So if user clicks the start sharing button but then clicks cancel, it will throw an exception and we see the exception message right here. Now let's go to screenrecorder.razor.js and examine this block of code. First, let's comment this block. If we run our application and click the start sharing button, select our screen and click the share button. Now if we click the stop sharing button right here, we see the video element displays a black screen and we still have the record button visible. Back to our JavaScript file, let's uncomment this block of code and see what's going on. First, we are handling the screen tracks ended event, which gets fired when the stop sharing button is clicked. And then we set video elements src object to null. This takes care of the black screen. Then we are calling a .NET method called screenEnded. This is done by using the .NET helper which we assigned to the video element. Remember, the .NET helper is a .NET object reference that got passed to this JavaScript function from our component code. If we go back to our screen recorder component, we have our method screenEnded. It's public and it's marked with the JS invocable attribute. The JS invocable attribute allows the method to be called from a JavaScript function. Inside the method, we are setting the recorder state to recorder state.idle, so it displays the start sharing button. Then we notify the component that its state has changed and it needs to re-render by calling state has changed. Now let's examine what happens when the record button is clicked. Inside the start recording event handler, we are using JavaScript Interop to call a function called getRecorder, passing in the video element. If we take a look at the getRecorder function, we see we are fetching the stream from the video element and storing it in a variable called screen. Then we are checking if the MIME type video/mp4 is supported by MediaRecorder, in which case we are constructing an options object whose MIME is set to video/mp4 and ext for extension is set to mp4. Otherwise, we are constructing an options object whose MIME is set to video/webm and ext or extension is set to webm. Then we are creating an instance of MediaRecorder, passing in the screen stream that we just got from the video element, and then we pass in the MIME type and we store it in a recorder variable. Down below, let's ignore these two pieces of code. We'll come back to them later. We are returning the recorder instance we just created back to the caller. And back to the screen recorder component, we store the returned object in an IJS object reference called recorder. And then on that recorder object, we are calling the start function. This starts the recording process. Then we are setting recorder state to recorder state.recording, which displays our pause, resume and stop buttons. Now during recording, the onData available event of our MediaRecorder object is fired, which we are handling here in our getRecorder function. Here we are simply getting the binary data and storing it in a chunks array that we have defined up here. Let's move on to the pause resume button. In the pause resume recording event handler, we are first checking if isPaused is true, in which case we are calling the resume function of our recorder object. Otherwise, we are calling the pause function of our recorder object. And we are toggling the value of isPaused. Finally, for the stop button, inside our stop recording event handler, we are simply calling the stop function of our recorder object. This fires the stop event of our recorder object, which we are handling inside the getRecorder function right here. Here we are creating a new blob instance, passing in the recorded chunks and the MIME type. Then we are calling url.createObjectURL, passing in the blob instance. This string now points to our blob and we store it in our MediaBlob URL variable. Below that, in these two pieces of code, we are stopping all the tracks in our screen stream so that our video element is now blank. Then we are using the .NET helper which was assigned to our video element to call a .NET method called recordComplete, passing in the MediaBlob URL and the extension which is either MP4 or WebM. Back to our screen recorder component, the recordComplete method is a .NET method that is public and marked with the JS invocable attribute. And inside the method, we are taking the MediaBlob URL that we got from JavaScript and storing it in a private field called MediaBlob URL. And we are using the file extension to construct our file name. Then we are setting isPaused to false just in case it was set to true and we stopped recording. Finally, we are setting the recorder state to recorderState.recordingComplete. This displays our restart and download buttons. When the restart button is clicked, we are setting recorder state to recorderState.idle, which displays the start sharing button. And the download button is a simple anchor element whose href attribute is set to MediaBlob URL. This MediaBlob URL is a string that points to the blob that we constructed in JavaScript. The download attribute is set to the file name, which will be either result.mp4 or result.webm. So that's it. With all this, we have a functioning screen recorder web app that records screen and system audio. And if you are interested in learning how to perform CRUD operations with Blazor in 60 minutes, watch this video here. Thank you.